Let's try solving the following genetics cross. A flower that is heterozygous for plant color and petal shape is crossed with a homozygous recessive plant for both flower color and petal shape. If a yellow flower color is dominant to white and entire shape is dominant to fringed, what are the F1 species and the ratios? Okay, so we know heterozygous for both color and shape, homozygous recessive for both flower and shape. So we know that we have yellow is dominant, white is recessive, entire is dominant, and fringed is recessive. So let's write out some abbreviations for us to help us. Yellow, if we use Y, we're going to have to be really careful because lowercase y looks a lot like uppercase Y. So if capital Y is yellow and lowercase is white, then entire shape, we can use capital E for entire and lowercase to represent fringed. So in this example, we have a heterozygous for both. And the first one looks like this. It's heterozygous at both positions, is crossed with homozygous recessive at both positions. And that'll give us. And so, what are the F1 species and the ratios? Ask, what are the F1 species and the ratios? And we can do this by Punnett Square, which will take quite a bit of time, or there's a second method, and I'll show the second method later, which I highly recommend, especially if your test is timed. But here's the Punnett Square example. So what we do is we split up the alleles like this. So you have these possible combinations, and you list these possible combinations in these top boxes here. So you have capital Y, capital E, capital Y, lowercase, lowercase capital, lowercase, lowercase. And then in the following, you just do the same, but you put them here. But you'll notice that all of these are the same because they're homozygous recessive. So in the boxes, this gives us the following. And you'll notice that in this example, since the left column is all the same, that the entire column is the same. So in this example, we have this. So you'll notice we have 4 possible groups in the F1 generation when crossing heterozygous for both with homozygous recessive for both. So in this example, we have 1/4 yellow and entire, with 1/4 yellow and fringed, with 1/4 white and entire, and 1/4 white and fringed. So here's these are your So in this example, this is your genotype. So the actual gene or the representation of it this is the genotype, and this is the phenotype, what the actual physical characteristic as a result of the genotype is. And then this would be the ratio of the phenotype. So now I'm going to show you a quicker way to do this type of problem without using the Punnett Square, but instead we're going to use the multiplication rule and the addition rule. And the way to do this is, in this example, we know we have heterozygous by homozygous recessive. So what we can do is treat each allele as a separate cross, and what that looks like is like this. And that'll give us the following. You do that with that, and that with that. You'll get YY, YY, lowercase, 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 lowercase. Or we can just write it like this. 1/2 is uppercase, lowercase, and the other half is homozygous recessive. And in this example, we have the same type of deal. We've got heterozygous crossing with homozygous recessive, and that'll give us the same ratios. So you have 1/2 capital E lower, 1/2 homozygous recessive. Now to find the ratio between these, what you do is you'd cross each of these. And that'll give us the same answer as this. You get 1/2 times 1/2 will give us 1/4 YY, capital E, E, 1/4 YY, lower, lower, 1/4 And so if you wrote out these characteristics, you'd see they're exactly the same. Wait, this one is... All right, so there's a good way to do this problem. Both are good, but I recommend doing this type of problem or this solution. So both are good ways to solve this problem, but I'd recommend doing this method because it's much quicker. If you do a couple practice problems, you'll get it down and you'll see that it'll save you a bunch of time, especially with more difficult problems.